Okay, a quick thing on exponential functions, in particular warming and cooling curves. General equation, as always, y or f of x equals a times the function, this is a function, plus c. A and c are your vertical manipulators. B is your vertical shifter, sorry, c is your vertical shifter. A is your vertical squish or stretcher. B is the base, which is different depending on how quickly the curve grows or cools. And 2 is a usual number, but it can be anything bigger than 1 is possible, anything greater than 1. So in the context of heating and cooling curves, all right, on the x-axis we're going to have time. So x will be time, y is temperature. And then you'd use the notation capital T bracket small t to indicate temperature at a certain time. So T bracket 0 would be the temperature, the initial temperature at time 0. Depending on the curve, all exponential functions all have this property of going through y equals 1 when x equals 0. And so this would be a warming curve. This is a cooling curve. They're reflections of each other in the y-axis. So the difference in the equation would simply be the sign on the exponent. Positive t, or positive time, and a negative t. So if you make a negative here, it makes it so it's a cooling curve. The values of A and C, so A could be the initial temperature, because at this one here, time 0 would give an initial temperature of 1. If you wanted that to be 4, then you could just have it, A is 4, and it becomes 4. But it's because the curve is stretched, not because it's shifted. If you want to shift the curve up and down, you use C for that. So C would move the curve either up or down. And what it would do is it would give you an different initial start point as well. Hope that helps.